This video will discuss Chapter 5.4, Solving Compound Inequalities. So in this lesson we're going to talk a lot about union and intersection. And so this would be a problem that's going to deal with intersection. These are inequalities that are going to be joined together. So this is my variable, obviously. Negative 2 is less than or equal to x minus 3. And x minus 3 is less than 4. So you're kind of looking at it almost like this, and then also like this, right? So you can kind of break it into two different problems. So the first problem is going to be negative 2 is less than or equal to x minus 3. And the second problem is going to be x minus 3 is less than 4. Right? So you can see that I just basically, the first side is this, the second side is that, right? So over here, what I got to do, and you're going to end up kind of doing the same steps on both sides. You shouldn't get the same answer. This is going to cancel out. This becomes positive 1 is less than or equal to x. And then over here, when I add 3, I've got x is less than 7, right? Because that cancels out. Now, a lot of times, or at least in the past, we've been telling you that you need to rewrite this where the x or the variable is on the left. For now, what I'm going to do is end up keeping this, because now what I want to do is essentially I kind of broke them apart, and now I'm going to end up pushing them back together. So I'm going to write this as 1 is less than or equal to x, and I'm going to use this, so this is that x, I'm going to use this x, because they are the same x, is less than 7. So it's 1 is greater than or equal to x, which is less than 7. So I want to show you how this is going to look on a graph. Okay, but again, in order to solve it or get myself to this point, because in order to graph it I need to be at this point, I need to isolate the x in the middle. And this is, of course, for an intersection problem where we're combining them. So if you take that, I've got 1 is less than or equal to x is less than 7. So I'm going to do when I graph this is I need to put 3 numbers on there now. Keep in mind I still need my 0. I got my 1. And then my 7. I want you to notice that I did not necessarily fill in all the numbers in between. But I do want you to notice that there is, it's not perfect, obviously. 7 should probably be more like over here. But it's clear that there is more space between 1 and 7 than there is between 0 and 1, which obviously there should be. All right, so now looking at this, on the 1, there should be a closed circle, right? Because that's what this is telling me. So I got a closed circle on 1, and I'm looking for all the numbers that are greater than 1, because x is greater than 1, right? Or I guess 1 is less than or equal to x, so I'm looking for 2, 3, 4, 5, 6. I can go all the way up to 7, but the thing is x also needs to be less than 7, and it can't equal 7. So that is going to be an open circle on 7, and then what I need to do is fill in the space between. So my graph should look something like that. It is closed circle on 1, open circle on 7, fill in the space between. Keep in mind I use this work to get me there. All right, so that's one problem that you're going to see. Now, if you take a look at this problem, that problem was an and. X had to be greater than or equal to 1 and less than 7. This one is an or. So a plus 1 can be less than 4, or a minus 1 can be greater than or equal to 3. Okay, we can talk about how in real life you might have some that are and some that are or. But so the idea is I need to solve this one first. And so solving this one, I'm going to subtract 1 from both sides. So a is less than 3. And over here I'm going to end up adding 1 to both sides. And so a is greater than or equal to 4. Okay, now I'm not going to put the a in the middle because this is not an and. So when the variable went in the middle, because it had to be greater than one number and less than another. In this case, it's going to be either or. So again, I need to get 0 on there, I need to get 3 on there, and I need to get 4 on there. Okay, and so I'm going to have an open circle on 3. Let's use a different color. So I'm going to have an open circle on 3. Right? That's because that's what this is telling me. And my arrow is going this way. Right? I'm not going to fill it in yet because I want to kind of see what's going to happen here. And then I've got a closed circle on 4. That's what this is telling me. Okay, and the arrow is going that way. So now what I can do is fill in the arrows because I've now figured out what this graph is going to look like. So I got one that's going this direction and the other that's going this direction, which means that if A is either less than 3 or A is greater than or equal to 4, there are only a finite set of numbers where this is not going to be true. Right? So it's all the numbers that are greater than 3 or less than or equal to 4, which is in this area, which will not work. Right? Which will not work. So anything that's in this area will not work. Now I misspoke. I said it's a finite. There's actually infinite number of numbers in between there, but at least we know the range. Right? It's not like this one will go on forever, this one will go on forever, this one isn't necessarily going on forever. Okay? There's a lot of numbers in there, but eventually we kind of can figure out that it's got to be between here and here. So that's what the graph is going to look like. So the key thing here is figuring out open circles and closed circles, okay, and making sure that your graphing or that your arrow is going in the correct direction. So really focus on what type of circle is supposed to be on that number. Is it open or is it closed? So is it greater than or equal to? And then which direction should the arrow go, and kind of figuring out what this graph should look like. Thank you very much for watching the video. Don't forget to do the problems on the bottom of the page. I'll see you in class.